Okay, this is our sixth module, 8086 microprocessor. So under 8086 microprocessor, uh, we will study architecture of 8086 microprocessor, and for 8086 microprocessor, then we will study register organization of 8086 microprocessor, then memory address space of 8086 microprocessor, and then pin diagram of 8086 microprocessor, memory segmentation, and calculating of physical address. Okay, so তোমাদের সিলেবাসে কিন্তু এইটুকুনি আছে ফর 8086 মাইক্রোপ্রসেসর। ওকে, সো ফার্স্ট আই উইল স্টার্ট জাস্ট okay, this is the architecture of 8086 microprocessor. Now, what are the features of 8086 microprocessor? Our 8085 microprocessor features basically it is 8-bit microprocessor, and it has 16 address line. Okay, 8-bit microprocessor means it can access 8-bit data at a time. Okay, but the memory address is our 16 bit. Okay, so using this 16 bit, that means for 8085 microprocessor we have 16 address line. So 16 address line means A0 to A50. Okay, so 2 to the power 16 means how much? This is 64 kilobyte. Okay, so 8085 microprocessor maximum access 64 kilobyte of memory. Okay, now for 8086 microprocessor, it has 16-bit data bus. Okay, 16-bit data bus, and it has basically 20 address line. So 20 address line means 2 to the power 20 means how much? Anyone? 1 MB, exactly. So 2 to the power 20 means 1 MB. Look at this, 1 MB of memory. Okay, so 8086 microprocessor can access the 1 MB of memory. Okay, memory is the external device of 8085 micro 85 as well as 86 microprocessor. This is another means separate chip. Okay, this is not inside the 8085 or 8086 microprocessor. Clear? So this is basically the separate chip. Okay, we can connect in 8085 as well as 8086 microprocessor. Now in memory we can store the data as well as instruction, same as our 8085 microprocessor. Okay.
Ma'am, what is the
Huh.
external chip you talked about?
External chip means this is means 8085 8086 microprocessor. It has architecture. Just look at this architecture, this one. There is no memory. We basically memory chip we externally connected.
Oh,
Okay,
okay.
where we can store data as well as instruction.
Okay.
Okay, basically this is the architecture of 8086 microprocessor. Now look at this. Here there is any memory location? No. Okay, we can see here register, general purpose register. Then this is segment register is present. Then instruction queue is present. Then temporary register present, flag register, ALU. But there is no any memory. Okay, memory is basically externally connected to the 8085 as well as 8086 or any kind of microprocessor, where basically instruction and data we can store. Okay,
Okay, ma'am.
so the features of 8086 microprocessor, this is 16-bit processor. That means it can access maximum 16 it can access maximum 16 bit at a time. Okay, and 20 bit address bus. Now look at this. Can you see this cursor?
Yes, ma'am. Yes, ma'am. We can see.
This is address bus 20 bit. Okay. So 20 bit address bus means A0 to A19. Clear? And 16 bit data bus means D0 to D50. So, and another features of this 8086 microprocessor, it provides segmented memory addressing capability. Okay, segmented memory addressing capability means uh, the externally connected memory which is connected to the 8086 microprocessor, this memory chip, okay, it is basically divided into 16 parts. Okay, and we can say each part, we can say code segment, data segment, stack segment, and extra segment. Code segment basically store the code, data segment store the data. Okay, but in 8085 microprocessor we don't have this kind of memory, segmented memory. Okay, but 8085 microprocessor we have total 64 kilobyte of memory chip, and this inside this memory chip we can store data and instruction, not means ওটা divide করা নেই, segmented করা নেই, but 8086 microprocessor we have segmented memory location, means for CS, that means this is code segment. Inside this code segment we can basically store the code of the instruction. For data segment we can store the data in DS, that means the data segment memory location. Clear, everyone? Any doubt?
No, ma'am.
Okay, now CS is code. This CS full form is code segment. Code segment basically store the code of the instruction. Data segment, now DS indicating this is data segment. This is indicating register. Okay, but in memory this is, look at this. Now a code segment, this is memory, code segment memory location, data segment memory location, extra segment memory location, stack segment memory location. Now stack data we can store in this memory location, extra segment memory location. Suppose our data segment memory location basically store the data. Okay, when this data segment memory location is full, okay, that time extra data we can store in extra segment memory location, and code segment memory location basically store the code of the instruction. Clear? This is outside the microprocessor. This chip is externally connected to the microprocessor. Okay, here we can store data, code, and stack information. Okay, and when microprocessor want to read the data or want to fetch the opcode, that time microprocessor read the data or fetch the data from this memory, because our data and instruction store in this memory location, not inside the microprocessor. Clear or not? Same as our 8085 microprocessor. Okay, so okay. So it provides segmented memory addressing capability. Okay. Now these are the features of 8086 microprocessor. Now next is our architecture. Architecture of 8086 microprocessor. Okay. Now architecture divided into two parts. Okay. One is our bus interface unit. We can say this is BIU, and another is our execution unit, that is our EU. Okay, so first I will explain, this is bus interface unit. Okay, now this part, look at this, this is the dotted line. The right hand side of the dotted line is our basically bus interface unit, and left hand side is basically the execution unit. Clear? Any doubt?
No, ma'am.
Okay. Now this bus interface unit basically It consists of segment register. Now this is segment register. CS, code segment register, data segment register, extra segment register, and stack segment register SS, and ES is our extra segment register. These all are register. Remember, okay? Now IP is called, this is instruction point, instruction pointer, and another thing, that is our instruction queue. Okay. Now this is instruction queue, 1, 2, 3, 4, 5, 6 instruction queue is present inside this bus interface unit. Okay. Now 1 indicating this is 8-bit register. Now 2 indicating this is another 8-bit. 3 is indicating another 8-bit. So total 6 byte. 8-bit means 1 byte. So this is, it can store instruction queue 6 byte. Okay, at a time. Now, basically bus interface unit, this part is connected to the memory chip as well as to the input output device. Same as our 8085 microprocessor. We know 8085 microprocessor. We have address bus and data bus and control bus. Okay. Now, address bus and data bus, basically microprocessor connected to the memory device as well as the input output device. Now here, uh, architecture is divided into two parts. That's why first part, this is bus interface unit, basically interface with memory device as well as input output device. So our memory device is connected here and our input output device is connected here. Okay. So execution unit is not connected to the our memory device and input output device. But this bus interface unit and execution unit internally connected. Clear? Clear? Am I audible?
না আরেকবার বোঝাতে পারবে?
Yes, ma'am.
আচ্ছা, এইখানে তুমি কার্সারটা দেখতে পাচ্ছ?
হ্যাঁ।
আচ্ছা, এইখানে দেখো 8085 মাইক্রোপ্রসেসরের আমার যে কার্সারটা যেখানে রয়েছে, হ্যাঁ, দ্যাট ইজ আওয়ার
হুম।
বাস ইন্টারফেস। ওকে, এই বাস, এই টোটালটা হচ্ছে আমার 8086 মাইক্রোপ্রসেসর। এর দুটো পার্ট আছে, একটা হচ্ছে বাস ইন্টারফেস ইউনিট, অ্যানাদার ইজ আওয়ার এক্সিকিউশন ইউনিট। ওকে, নাও এই বাস ইন্টারফেস ইউনিট বেসিক্যালি connected to the memory chip and input output device. ওকে, মিন্স আমি এই রাইট সাইডে কি করি, মেমোরি ডিভাইস কানেক্ট করি। এই মেমোরি ডিভাইস বেসিক্যালি বাস ইন্টারফেস ইউনিট কি করতে পারে, ফেচ দ্য ইনস্ট্রাকশন ফ্রম দ্য মেমোরি ডিভাইস and read the instruction from the memory device and write the instruction into the output device. Okay, that is responsible for bus interface unit. Okay, now execution unit only responsible for execution part. Okay, that will I will explain. So this is our bus interface unit. Now next point, this bus interface unit means our right hand side unit basically compute and send out address, fetch instruction code, store store the instruction code in a instruction queue. This is first in, first out register set. Now, how many register is present here? 6 register. Okay, and each register is consist of 8-bit data. That means each register can temporarily store 8-bit data. Okay, so this is first in, first out. First in, first out means when a bus interface unit, suppose fetch the instruction, first fetch the instruction or fetch the opcode from the memory, okay, and this opcode is first entered into the instruction queue. Okay, so first is, first register 1 store this opcode. Okay, Now second, it reads the instruction code, store here. Second, third, store another instruction. Fourth, fifth, sixth. Okay. Now it can store maximum 6 bytes. Okay. So now when this execution unit, basically execution unit, uh, uh, execution unit takes the data from or instruction from this instruction key. Okay, that means first instruction, this is opcode, is sent to the execution unit. Okay, now execution unit basically execute this instruction with the help of ALU, flag register, and general purpose register. Okay, now this is our first in and first out. Okay, now second one, so this is 2 is transfer here, so this is 1 2 3 4 5 is present, another register is empty. Now another instruction output is fetched from the memory and stored here. Okay, this will continue. So this is the instruction queue. Now this instruction, this bus interface unit and the execution unit basically work parallelly. Okay, but independent. Clear? Clear up to this? What is instruction queue? Okay. Now, hmm, exactly. Six of course. No, 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 not at a time. One by one. That is depend on first in, first out. Okay. No, 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 no. First axis one, first in, first in করেছে one, so first out one. Then second in, second out. Third in, third out. Okay. So when 16, 16 means 6 is come here. So remaining are empty. So another 5 output are stored in this instruction. Clear? That follows basically the first in, first out. So here, one important question is what is instruction queue and how it's operate. Okay. Now, next one, execution. Now, next part is our execution unit. Okay. Now, this execution unit basically it consists of register. This is general purpose register AHAL. Okay, and it is indicating AX. AX indicating this is 16 bit. Okay, BX indicating this is 16 bit. AH indicating higher order of A register content. AL is lower order of accumulator. A is indicating accumulator here. Similarly here, this is 8 bit, this is another 8 bit. So total we can access PX is 16 bit. Now for 8085 microprocessor, we can see we have 8 bit register, general purpose register. That is B, C, D, E, H, N. Because 8085 is a 8 bit microprocessor. Now, when 8085 microprocessor PC pair B is pair with C, then we can say this is PC register pair. Okay. Now that is our 16 bit. Now here that is BX. We indicating by BX. Okay. Now in 8085 microprocessor, we can see PCDE. Okay. Now here this is DX. Okay. Now CX. Now, this register A is indicating the accumulator, B is indicating basically the base register. I will explain what is base register. Okay. Now, this one C is indicating the counter. That means it counts the number. Okay. Now, we can see in our laboratory, we performed an experiment that is our, I think, count a 16-bit number. Okay. and store this number in some memory location. Now here we আমরা কি লিখেছিলাম c তে c equal to 16. Okay. Now when one byte transfer from one memory location to another memory location, now c is decremented by 1. Okay. And this loop is continue up to when c equal to 0. Okay, so this c is basically the counter. The content of cx register becomes 0. Such instruction terminate our execution. Okay, so this is c is indicating the counter register. And D, another is our D. D is used for memory addressing. For memory addressing, we use D. Now remember, for 8085 microprocessor, we use HL pair for memory addressing. Now here DX we can use for memory addressing. Clear?
Which one? DX?
DX. DX?
No, it will be
No,
16
no,
bit, I think.
16 bit,
16. Yes.
not 32
8
bit.
plus 8.
DH is 8 bit, DL is another 8 bit. So this is 16 bit. 8086 microprocessor is a 16-bit microprocessor, not 32-bit microprocessor. Clear? 80386. Write down 80386 is a 32-bit microprocessor. Okay. Now this one is our 16-bit microprocessor. Now, next is our execution unit. Now, this is general purpose register. Now, SP indicating stack pointer. Okay, PP is indicating base pointer. I will explain everything. DI is indicating destination index. SI indicating source index. And another is our temporary register, ALU flag register. That is under our execution unit. Okay. Okay, now this is internal control system. That means our timing and control system, that is also the part of our execution unit. Okay, now basically execution unit receive the opcode of an instruction. Execution unit receive the opcode. Now basically opcode is stored where? First memory location, microprocessor read this opcode from the memory location, store in the instruction queue. Okay, and execution unit basically receive this instruction from this key. Okay, not memory. It receives the instruction code from this instruction key. Okay, and decode it and then execute this opcode. When execution unit is decoding an instruction or executing an instruction, the BIU, that is bus interface unit, fetch the opcode from the memory and store it in the instruction key. That means when this execution unit basically decode the instruction or execute the instruction, that time this bus interface unit basically fetch the opcode or read the opcode from the memory. Okay, and store it in the instruction queue. So this BIEU, execution unit, and bus interface unit basically operate in parallel. Okay, that means when this executing the instruction, it that time this bus interface unit fetch the opcode. Okay, so this is parallel work. This kind of overlapping operation is called pipelining. Underline. This type of overlapping operation is called pipelining. Okay. So another question will come. They ask, what is pipelining? Okay. So what is the pipelining architecture of 8086 microprocessor? Write down the question. Okay. Am I audible?
Yes,
Okay.
ma'am.
So
Yes, ma'am.
anyone? Okay. Anyone just tell me what is pipelining architecture of 8086 microprocessor? Anyone?
The overlapping instruction and execution.
No. You have to basically डिटेल में तुम्हें बोलना हो पड़ेगा. This kind of overlapping operation that is called pipeline. Exactly.
मैम
So this
एक बार ही डेफिनेशन लिखवा दीजिए ना.
okay. While execution is unit, while execution unit execute instruction, the bus interface unit fetches the instruction from the memory,
Fetches the.
instruction from the memory and store in the instruction queue. And store in the instruction queue. The execution unit and bus interface unit operate in parallelly parallel independently. The execution unit and bus interface unit operate in parallel independently. This type of this type of overlapped operation of the functional unit of a microprocessor. This type of overlapped operation of the functional unit of a microprocessor is called pipelining. Pipelining. Pipelining.
Okay, ma'am.
Can you see this Jamboard?
Yes, ma'am.
So pipelining. Pipelining. ওকে, অ্যাকচুয়ালি আমি না আমার ইয়েটা কি বলে রাইটিং প্যাডটা আনতে ভুলে গেছি, না হলে রাইটিং প্যাড দিয়ে করালে কি লেখাটা খুব স্মুথ হয়। নেক্সট ক্লাস থেকে আমি ওটা নেবো, একদম ভুলে গেছি, অনেকদিন পরে অনলাইন ক্লাস তো আমি বাড়ি থেকে আনতে একদম ভুলে গেছি। ওকে, নাও this is called pipelining architecture. Okay, so this is the architecture of 8086 microprocessor. Okay, so any doubt from this architecture part? I will explain each and every box inside this 8086 microprocessor. Any doubt? Here IP. Okay. Here IP. I will explain everything. Here IP is similar to our PC. Okay. Only difference here instruction queue is present, but 8085 microprocessor there is no instruction queue. One instruction fetch from the memory location, and microprocessor read this instruction, and microprocessor decode this instruction and execute this instruction. Okay, and then microprocessor receive another opcode from the memory. Clear? One by one. But here, two operations are performed parallelly. One is our opcode fetch from the memory, and it is stored in instruction queue, and execution unit take out this opcode from receive this opcode from the bus interface unit and execute. Okay, when execute, that time bus interface unit fetch the opcode parallelly fetch the opcode from memory. Okay, so this is the difference between architecture perspective. This is the difference between 8085 and 8086 microprocessor. 8086 microprocessor basically very fast because two operations are performed parallelly. Okay, but 808 instead 8085 microprocessor, one instruction fetch, and then it decode execute, and then after completion of this execution, microprocessor fetch the instruction from the memory. Okay, that is the difference. And another difference I will explain. Now, before going to explain each and every detail, okay, first I will explain the memory address space. That is okay. Now, look at this. Can you see this one? Linear addresses. Memory segmentation. Can you see this PPT slide?
Yes, ma'am.
Okay. Now, already I have explained this. This is for 8086 microprocessor can access 1 megabyte of memory. Okay, so 1 megabyte of memory means 1 megabyte of memory. To access this memory, microprocessor requires 20
20,
address
20
lines.
address lines.
Exactly. Okay, 20 address lines. Now, for 8085 microprocessor, we can see 16-bit address line. Now, this is just a minute. Now, here, look at this. Can you see the cursor? Okay.
Yes.
Now, last one, just one, two, three, four, five. 5 bits are present. Okay. Each zero is indicating 4 bit, 4 bit, 4 bit, 4 bit, 4 bit. That means how many bits? 5 into 4, 20 bits. Okay. So the starting address of memory is 00000. Okay. Now our 8085 microprocessor static address is 16 bit. That means 0000. 4. 40. Clear? Clear everyone?
Yes, ma'am.
Okay. So this outside address is called the physical address or physical address. This is called physical address. Okay. Now, this physical address, the maximum range is how much? 1 megabyte. Now this 1 megabyte of memory is divided into 16 parts, 1 6. Okay, so each memory 16 parts. So if 16 segment is present, that means each segment correspond to how much? Each segment, if we consider this is one segment, this is two, three, four, five, six. Now here total 16 segment is present. Okay. So 1 megabyte divided by 16 equal to 64 kilobyte. Okay. So if this gray color portion, if I consider this gray color portion, okay, so this is 64 kilobyte. Now this white color portion 64 kilobyte. This is 64. So each segment is 64 kilobyte. Clear up to this? This is very important for 8086 microprocessor. Just look at this figure. This address is called our physical address. Okay. Now total memory. Total memory is 2 to the power 20 is 1 megabyte. So this is our 1 megabyte of memory. Is divided into 16 segments. 16. So one segment equivalent to how much? Rohan, how much? 64 kilobyte. Okay, 64 kilobyte. So if I consider, so each segment is 64 kilobyte. Now here this is one segment. It is 64 kilobyte. This is another segment. Now I consider this is also 64 kilobyte of memory. Clear? So one segment equal to 64 kilobyte. Now this is similar to our 8085 microprocessor. Am I right? Okay. For 64 kilobyte memory, we need how many address lines? Should tell
16.
60 address lines. Okay. Clear up to this? So this is our one segment. Okay. Now this segment physical address. This segment physical address start 80,000 to 90,000. Means 90,000 is the starting address of the next segment. But the 80,000 starting address of this gray color segment and end is our 9FFFF is the, sorry, 8FFFF is the our end address of this segment. Can I repeat this one? Can I repeat this one? 80,000 is the starting address of this segment, gray colored segment. If I consider this, okay. So 80,000 is the physical address, starting address. Okay. So ending address क्या होगा रोहन? 8. This is 80,000. 80,000 means 8. Next 40 is present. Okay. So ending address how much? 8. F. Clear? Clear everyone?
Yes, ma'am.
Yes.
Okay. So now this outside address is called physical address. Okay.
It's called
And
what?
Physical address. Physical.
Physical address. Okay.
Exactly. Okay. And the upper 16-bit address of physical address. Upper 16-bit of this physical address means which one? Darshit? Physical address is 80,000. Its upper 16-bit means
Upper
how much?
16-bit is 8
Zero,
80.
zero, zero. 16-bit means 4 into 4. So 4 bit,
Yes.
1, 2, 3, 4, 8,000.
हाँ 8,000 हो गया.
Exactly. This upper 16-bit address is called segment address.
Oh, okay.
So this segment address, starting address is 8,000. Okay. And another address is present, that is our offset address. That means this address is 8,000, starting address of this segment. Okay. And ending address of this segment is how much?
9,000.
Before
Oh नहीं
9,000,
sorry sorry 8 FFFF हो जाएगा.
8 F F F F, 8 into F, 3 times F. Okay. So now this is 64 kilobyte. Now each 64 kilobyte we in 8085 microprocessor we can see the address start from 0000 to FFFF. Okay. Now this 0000 is called the offset address of this segment. If I consider this one, this dotted line, okay, now the offset address is 0250. Okay, now segment address is how much? Segment address is 8,000 plus offset address is 0250. So it's indicating 8000 to 0250 memory location. Clear this one? What is segment address? What is offset address?
Yes sir.
Hmm. It is the maximum address of this segment. Now for 8, 8FFF 4F means 8,000 is indicating this is the segment address. This segment address is 8,000 starting address. Okay, and this is the segment address indicating, not offset address. Now 64 is divided. 64 kilobyte means how many address line required? 16 address line. That means 4 into 4. Okay. Now each address. Now this is suppose this is 0000 address. Now next one is 0001, 0002 like this. Okay. So starting address of this segment 8,000 and the offset address of this point is 000. Now this is starting address of this segment 8,000 but offset address is our 1, 0001. Clear? This indicating our starting address of the segment and this indicating our offset address of the segment. Now this segment maximum length is how much? 64 kilobyte. So to access this 64 kilobyte, we require 16 address line. That's why this is 4 bit. Clear? So this is our segment address. This one is our offset address. Now, one more thing. Now, this segment at uh, suppose example. Okay. Now, if I consider D 4 times 0 segment, starting address, physical address start D 4 times 0. Write down D 4 times 0. This is the physical address. Okay. So from this, uh, what is the segment address?
D000.
D 3 times 0 is
Yes,
the
D three
segment
times
address. Okay. And offset address start from,
0. 00000.
that means 00000 to how much? Maximum?
FFFF.
FFFF. Okay. Now for 8086 microprocessor, we have to write segment address dash then offset address. Okay.
Oh, okay.
8085 মাইক্রোপ্রসেসরে কোনো সেগমেন্টেড অ্যাড্রেস ছিল না। Clear? Now 8086 microprocessor, it has segmented address because segmented memory location is present. Now next one, how to calculate this physical address. Suppose we have base address, that means segment address, okay, and we have offset address given. How to calculate the physical address? That means this left hand side address. How to calculate? Anyone? Any idea?
सबसे पहले तो हम लोग को अगर सेगमेंट एड्रेस दे दिया है तो दीज आर द फोर फर्स्ट लेटर्स, मतलब फर्स्ट फोर नंबर्स होने वाले सेगमेंट एड्रेस.
Hmm.
तो फॉर एग्जांपल अगर हम लोग को सेगमेंट एड्रेस दिया हुआ है F000, तो
Hmm.
हम लोग फिजिकल एड्रेस में पहले तो F000 लिख देंगे, और फिर जो
Hmm.
लास्ट वाला हम लोग को ऑफसेट एड्रेस दिया है
Hmm.
उसको हम लोग उसका इक्विवेलेंट मतलब 1 बाइट मतलब उसका इक्विवेलेंट डेसिमल में कन्वर्ट करेंगे, मतलब 4 बाइट से जो वन वन बाइट में फोर फोर नंबर से जो 1 नंबर में करते हैं, मतलब बाइनरी
हाँ.
करके. जैसे अगर 0 है तो 0000 हो गया, अगर F है तो FFFF हो गया वैसे.
Okay. But one more thing you have to remember, this segment address is the upper 16-bit address.
हाँ, अपर 16 बिट हो जाएगा.
Upper 16-bit address. So this is the 16-bit, means for 16-bit, but physical address consists of 20 bits.
20 बिट तो
Okay, so you have to shift this 8000 or any segment address, okay, 4 times to the leftward direction. Suppose I consider 60,000. Suppose I consider here, just look at this Jamboard. Okay, suppose our given segment address given, that is 2000. Okay, offset address given, suppose 5623. Okay, we have to calculate physical address. Okay, so physical address consists of 20 bits.
20 बिट.
Okay, so formula is physical address is equal to segment address
सेगमेंट एड्रेस
segment address
into
plus plus
अच्छा directly plus कर
offset
offset
address. Okay. Now segment address is given 2000. So we have to shift. This is 4 by 16 byte, a 16 bit,
16 bit
but
yes
physical address consists of 20 bits.
20 bit
So we have to shift this segment address leftward direction. That means 2000 we can write 2000 means 0 0 0 0, another
2
0 0 0. Okay. Now 10 20 0 0 0 0, and then 2. In binary we can write. Okay. So we have to shift this one left hand side 4 times. Okay. So we can write here another 4 times 0, because this 4 times shifted this one, and this one. So we added 0 0 0 0. Clear? So this one is our first. We have to shift it our segment address 4 times left hand side. So we can write this is 2 0 0 0 0. Clear? Clear everyone? Shutam,
yes sir
clear?
Yes, ma'am.
Okay. Now you have to add the our offset address. Offset address how much? 5623. Okay. So 5623 means 5 means 0 1 0 1 5. 6 means 0 1 1 0. 2 means 0 0 1 0. 3 means 0 0 1 1. Okay. Now add this. So this one 0 1 1 0 1 1 0 0 0 0 0 0. Okay. Same here 0 1 0 0 0 1 0 1 0, and this one is our 0 0, sorry, 0 0 1 0. So what is the physical address? This corresponding to, and this corresponding 5. This is 6 2 3. Clear?
yes ma'am
কার ক্লিয়ার হলো না? চন্দন,
Ma'am, yes, ma'am.
চন্দন,
Ma'am, uh, offset address. It's not clear, madam.
ओके. अच्छा, सो तो नहीं गए ना अभी?
नहीं मैम नहीं सर
अच्छा. আচ্ছা, রনিতা,
Yes, ma'am.
হ্যাঁ বুঝতে পেরেছো কি করে ফাইন্ড আউট করলাম ফিজিক্যাল অ্যাড্রেস?
হ্যাঁ হ্যাঁ
রিতম,
Yes, ma'am.
রোহন, ওকে, শ্রাবন্তী,
হ্যাঁ ম্যাম, আর একবার বলবে একটু, বললেন একটু ভালো হয়,
আচ্ছা,
ঠিক বুঝতে পারিনি।
ওকে, সৌমাবু,
হ্যাঁ হ্যালো ম্যাম।
সৌমদীপ,
হ্যাঁ ম্যাম আরেকবার।
আচ্ছা, শুভদীপ। শুভদীপ,
ম্যাম অফসেট অ্যাড্রেসটা বুঝতে পারিনি।
শুভম সরকার।
হ্যাঁ ম্যাম, অফসেট অ্যাড্রেসটা আরেকবার বললে ভালো।
আচ্ছা, সুতম পাল।
হ্যাঁ ম্যাম।
বুঝেছো না
ইয়েস।
বোঝোনি? ওকে। বল। এক সেকেন্ড, একটু হোল্ড করো তো, একটু হোল্ড করো। হ্যাঁ বলো। হ্যাঁ হ্যাঁ, নিয়ে এসো। লঙ্কা ছাড়া, হ্যাঁ। ঠিক আছে। না না, আর কেউ আসেনি। ঠিক আছে, হ্যাঁ। হ্যাঁ বলো, আরেকবার বলো, কি কোশ্চেনটা করলে? সেগমেন্ট অ্যাড্রেস। এক সেকেন্ড। 2 1 1 1. Okay. What about our offset address? Offset address 5623. Okay. So physical address equal to
Should I
segment
try
address.
this on the board, on the Jamboard?
Huh? Yes,
Should
yes.
I try this on the Jamboard?
I'm writing in the Jambu. Okay. So 21111. Okay. So physical address equal to segment address plus offset address. Okay. So first segment address we have to shift it 4 times left on side. Okay. So 2 1 1 1 shifted left hand side 4 times. So here 1 0 is added. Here this is 4 byte. Now here this is our 5 bytes. That makes our 20 bits. Okay. Now this is our add with this offset address. Offset address is our 5623. Okay. So 33762. This indicating the physical address. Clear?
Yes, ma'am.
Rohan? Okay. So this is, we added this one left hand side. So you can write this one in binary form also. 2 means write down in binary 1 1 1, then 0 0 0. Okay. Now here same thing and then add. So this is the physical address of our. Now this is our segmented memory. Now if I consider this one and our base address, that means our segment address starting is 2111. Okay, this is our segment address. Write down, and this address, now offset address start is 0 0 0 0 2 F F F F. Okay, but my value indicating 26733. Okay, so physical address, which one indicating? This is our segment address, not our physical address. Okay, now this is the segment address and the physical address we can write this is our physical address 26733. Clear? This indicating our segment address, starting address, and this is indicating offset address for each and every segment. Offset address start from 0000 to FFF maximum. Okay, and physical address is our 5 bytes. Clear? So segment address is F F F F. Okay, this one ऐड करो, एक कैरी जनरेट होगा।
फ्लैग में चला
अगर
जाएगा क्या?
कैरी जनरेट
फ्लैग
हो गया, इसका
फ्लैग में
मतलब
चला
क्या है?
जाएगा,
वो
फ्लैग में
एक्सेस
चला
कर
जाएगा।
पाएगा, वो 20 बिट्स होगा, वो 21 बिट्स हो जाएगा। तो कैसे एक्सेस कर सकते हो ये मेमोरी? नो, इसका मैक्सिमम रेंज क्या होगा एक सेकेंड? एक सेकेंड একটু হোল্ড করো। হ্যাঁ বলো। हाँ बोलो, आप तो हाँ। हेलो, एम आई ऑडिबल? हाँ हाँ बोलो। हाँ, मैं क्या क्या हो सकता है बोलो? तुम बोलो कैसे, मीन्स क्या हो सकता है इन जनरल?
मैम हम बताएं,
बोलो।
अगर हम लोग सेगमेंट एड्रेस का मैक्सिमम भी अगर हम लोग एफ लेते हैं, तो उस केस में अगर हम लोग ऐड करना है एफ तो हम लोग का मैक्सिमम ये क्या बोलते सेगमेंट एड्रेस हो सकता है ई एफ सॉरी ई और फिर 3 बार एफ। तो उस केस में क्या होगा कि अगर हम लोग का ऑफसेट एड्रेस एफ 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 भी होता है, ई एंड देन 3 बार एफ,
E
3 बार एफ, तो उस केस में अगर ऑफसेट एड्रेस एफ 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 भी होता है तो उस केस में भी मेरे ख्याल से हम लोग रेंज में रहेंगे,
ये
मैक्सिमम ऑफसेट एड्रेस एफ
अगर
एफ।
एफ 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 एफ, हाँ ये तो मैक्सिमम एफ 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 ही होगा।
हाँ हाँ ऑफसेट एड्रेस।
ठीक है, तो एफ, ओके, ये शायद एक कैरी जनरेट होगा, ये इसके साथ ऐड होगा ई के
हाँ
साथ, तो इसका एफ होगा, तो मैक्सिमम सब एफ 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 होगा।
एफ 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 ये
हाँ,
मैक्सिमम होना चाहिए ना।
तो ये रोहन ये एक बार कर लो, तो इसमें बाइनरी में लिखो इसको, देखो कर कर देखो। ई मतलब 14, 8, 12, 14, देन E F F शुभम के वर्ड से, शुभम
Yes, ma'am.
হ্যাঁ বলো কি হবে, আমি তো ক্যালকুলেট করছি। দেন ম্যাক্সিমাম অফসেট অ্যাড্রেস ইজ FFFF, ওকে, দেন 00 অ্যাডেড, ওকে, so FFF, इसमें तो 000 हो जाएगा। हाँ क्या हो रहा है फिर, F 5 आ रहा है, तो सेगमेंट का मैक्सिमम एड्रेस क्या होगा, EFFF, ठीक है। रोहन, तुम देखो 1 मेगाबाइट जो है ना, उसको एक्सप्रेस करने के लिए मैक्सिमम एड्रेस ये आता है EFFF। अगर FFF है उसका मतलब सेगमेंट एड्रेस उस कैरी जनरेट हो जाएगा, सो 28 बिट 21 बिट हो जाएगा, वो एक्सेस नहीं कर पाएगा, ठीक है। तो दिस इज हाउ टू कैलकुलेट फिजिकल मेमोरी एड्रेस। नाउ वन मोर थिंग, slide, now this address basically physical address already calculated. Now this total physical memory divided into 16 segments, and this segment, one of the 16 segment is code segment. Okay, this is 64 kilobyte data segment, extra segment, and stack segment. Okay, now these two means each segment. Now extra segment is separated by the stack segment by some gap. Okay, always remember. Now next one, the data segment. Data segment, this memory location only store the data. Okay, now what is memory? Memory is basically consists of registers. Registers is consist of flip flops. Okay, so this is consist of 8-bit data segment register, we can say. This is code segment, 8-bit code segment register. Okay, stack segment register, extra segment register. Okay, now next point. So here 7,000. Now if I consider this one, so 70,000, our ES extra segment and starting address is 7000 and the top address of this 7FFF. Okay, and for last memory location, now physical address is FFFFF. So before this FFFFF, last address is our last one is our E means for segment address. Last is our EFFFF, three times. Okay. Now next. Next, I will explain the code segment, data segment, extra segment, and stack segment, extra segment, and instruction pointer register. Okay. Now write down one more thing. This is very important. Write down, then I will explain. For code segment, write down this is segment and this is offset. Code segment register and offset register. If we consider code segment, okay, then code segment register is used and that time offset addressটা কোন register hold করবে, that is our instruction pointer. Write down instruction pointer. If we indicating code segment memory, that time always remember offset address register is our instruction pointer. If we indicating stack segment memory location, offset address hold BP base pointer register or SP. SP is our Rohan, SP stack pointer. Base pointer, stack pointer. If we consider DS, data segment memory, then offset address hold the register SI register, hold the offset address. SI means source. Hello. Okay.
Yes, ma'am, you're right.
Source index register. SI indicating source index register. And last one is our DES, extra segment memory location. DI, destination index register, hold the offset address. Code segment memory location, offset address fixed, that is fixed. ওকে, কখনোই কোড সেগমেন্টের অফসেট অ্যাড্রেস হোল্ড করবে না ডিআই, কখনোই স্ট্যাক সেগমেন্টের অফসেট অ্যাড্রেস হোল্ড করবে না এসআই। ওকে, অলওয়েজ ফিক্সড দিস ওয়ান ফর কোড সেগমেন্ট আইপি, extra segment BP or SP, DS is indicating SI, ES for DI. Okay, remember this one. Now next one. Okay. Segment. This is segment register, not segment. Each segment. Suppose this is code segment. Okay. কোশ্চেনটা কি করলে রোহন? Segment register hold the segment address. Code segment register hold the code segment address, not physical address. Segment address. Okay, starting address of the segment. Okay, and this is indicating by IP, and IP hold 00000 to FFFF, 4 bit, and that is also 4 bit. Okay, now we shifted this 4 bit left hand side and then added, we will get physical address. Now next is slide. Okay, now register organization. Okay, now for 8086 8085 microprocessor, we have how many registers? General purpose register. General purpose register 7. Huh? 6. So 6. B, C, D, E, H, L. 7. আমি কাউন্টিং ভুলে গেছি হয়তো। No, accumulator is not the general purpose register. Accumulator is special purpose register. Okay. We can access accumulator, but accumulator is special purpose register, not general purpose register. Okay, accumulator, then our stack pointer, then our program counter, all are special purpose register, not general purpose register. Okay, for 8085 microprocessor. For 8086 microprocessor, we have all 4 general purpose register. Okay, that is AX, BX, CX, DX. Already I have explained. A indicating accumulator, B is basically indicating the base register, and C is indicating counting purpose, D indicating to hold the address of the instruction. Okay, now next is our pointer, SP, pointer and index register. What is SP? SP full form is stack pointer,
Yes, ma'am.
stack pointer SP. So SP is for 8085 microprocessor. SP is hold the stack address of stack top location. Okay. Now here is same for 8086 microprocessor. Okay, it indicating the stack top memory location. That is our stack segment memory location. Remember, now 8085 microprocessor কোনো segmented memory ছিল না। ওকে, সেই জন্য আমি কি বলছিলাম, stack top memory location, but 8086 microprocessor segmented memory is present, so it hold the stack top memory location in stack segment. Clear? Now BP. BP is called the base pointer. Okay. BP is called basically the base pointer. And SI is indicating is our source index register. Now source index register and destination index register. Basically source index register, this register generally used to store the offset address of data. Basically SI is store the offset address of our data segment. Now this one SI basically hold the offset address of the data segment. TI index register hold the offset address of extra segment. Okay, and these SI and DI basically used for store data temporarily, not permanent. Okay, Now this is our register organization. Now next one is our, just a minute. Now next one is our instruction pointer. Instruction pointer, same uh, for 8085 microprocessor we use PC. PC is equivalent to IP here. Instruction pointer. Okay. It holds the address of the next instruction to be executed. Okay. Its content is automatically for PC. We can see for execute when microprocessor execute the current instruction, PC hold the next address of the instruction. Okay. Now this PC content is automatically implemented after execution of on instruction. So same here, its content is automatically implemented. Now the content of instruction pointer. Content of instruction pointer and the content of code segment register used to, now look at this, the content of our content of IP instruction pointer value and the content of code register value, code segment value. Okay, we will get কি পাই আমরা, we will get the physical address of this code segment. Okay, now next one, suppose we have a code segment, the same example. If our code segment value is 50,000 and the IP address is 1111, so physical address is 50,000 and IP address is suppose 1111. Physical address is given 50,000. Okay, 50,000 and this is our physical address. Sutam bolbe. This is our physical address and offset address given this one. Okay. What about our segment address? Sutam.
ম্যাম 5000 আছে ও
5,000 is our segment address. Okay. This is our segment address. Clear up to this one? Segment address we can find out from physical address. Now upper 16 bit of physical address is indicating the segment address. Just reverse. আমি কি বলেছিলাম এতক্ষণ, offset address, segment address given, how to calculate physical address. Now here physical address given, offset address given. Now find out the segment address. Clear? So we can write this is 5,000 segment address and offset address is 1111. Clear? Okay. Now, acha, up to this, any doubt? Anyone? Then I will start. Pin diagram. Only two portion left. That is our pin diagram and flag register content. That's it. Up to this, any doubt?
হ্যাঁ আরেকবার দেখান ওটা,
কি বলবো আরেকবার?
ওই ডায়াগ্রামটা দেখান একবার,
কোন ডায়াগ্রামটা বলো?
পিন ডায়াগ্রাম।
হুম।
এখানে ডেটা লাইন আর অ্যাড্রেস লাইন একসাথে,
হ্যাঁ, সে
ওই
তো আমাদের
লেফটে।
8085 এরও একসঙ্গেই ছিল।
হ্যাঁ
কেন ছিল? প্রেজেন্ট কি
ইয়ে
বলেছিলাম?
আহ,
রোহন কি বলেছিলাম? ये जो एड्रेस एंड डेटा लाइन आर मल्टीप्लेक्स here. Why? To reduce the pin number. No number. To reduce the pin number. If we can use for address we can use A to 20 pin, and for data we can use D to 16. So we require basically 20 plus 16. Okay, 36. Now here multiplex address cum data bus we use, so we require 20 bits. That means 20 pin instead of 36. Okay. Sometimes it acts as a data bus, sometimes it acts as a address bus. Okay. One more thing before explaining this pin diagram, in 8086 microprocessor operate in two modes. One is our minimum mode, another is our maximum mode. Okay. From these, one question they ask, what are the differences between minimum mode and maximum mode? Okay. So for minimum mode, only one processor is present. That is our 8086 microprocessor is present. Okay. When multiple processor present with 8086 means 8086 থাকবে, along with 8086 some other processor also present. Okay, then this mode is called maximum mode. Okay, so 8086 microprocessor minimum মোডেও কাজ করতে পারে, maximum মোডেও অপারেট হতে পারে। Okay, for minimum mode operation we require some different signal. For maximum mode operation we require this RQ by GT0, but this signal S2 S1 S0 QS0 QS1, this signal are used for operate in maximum mode, and this signal are used for minimum mode. Okay, for minimum mode, multiprocessing cannot be possible, so performance is poor. For multiprocessing, for maximum mode, multiprocessing is possible because multiprocessor we can use along with 8086 we can use 8087, 8089 processor we can use. Okay, so for this purpose the performance is very high. Okay, that is 5 marks question. Okay, so next class Thursday I will explain pin diagram and flag register. Okay, so then তাহলে আমাদের 8086 microprocessor, that means our 6 মডিউলটা কমপ্লিট হবে। Then come next week I will start 8254. Okay, then microcontroller. हाँ, क्वेश्चन बोलो। बोलो।
इट्स स्टिल 8 बट क्या है, डबल हो गया है, नंबर ऑफ रजिस्टर्स डबल हो गया है। जैसे AH है तो एक्यूमुलेटर का हायर कंटेंट्स 8 बिट में स्टोर हो रहा है, AL मतलब एक्यूमुलेटर का लोअर कंटेंट 8 बिट में स्टोर हो रहा है। तो अभी भी जो रजिस्टर है मेरे ख्याल से वो 8 बिट ही है, बस खाली नंबर ऑफ रजिस्टर्स बढ़ गया है, तो हम लोग 16 बिट बोलते हैं उसको। सही बोला ना मैम? AH 8 बिट हो गया, AL 8 बिट हो गया, बट अगर तुम एक्यूमुलेटर का बात करेगा तो हम लोग बोलेंगे वो 16 बिट है। बट है तो अलग अलग ही मैम, अलग अलग ही है ना, AH अलग रहता है और AL अलग रहता है ना, मतलब
हाँ,
फिजिकली।
जैसे इसमें हम लोग क्या यूज करते थे 8085 में BC, B 8 बिट, C 8 बिट, 16 बिट। Okay, B C D E H L. Now here AH means AX is indicating
16
16
bit.
bit. Okay, AH is hold upper higher 8 bit and AL is hold lower 8 bit. And for port segment, this is port segment register. Okay, port segment register, this is 16 bit or 8 bit. Anyone? Port segment register is hold basically the codes means hold basically the instruction code. Okay, so this is 16 bit or 8 bit.
16 बिट हो जाएगा ना?
बोलो. তুহিন, তুহিন, তুহিন আছো?
Yes, ma'am.
বলো কি হবে অ্যান্সার? বলো কোড সেগমেন্ট রেজিস্টার বা এক্সট্রা সেগমেন্ট রেজিস্টার বা ডিএস ডেটা সেগমেন্ট রেজিস্টার হোল্ড করবে কত বিট, কত বিট ডেটা? এখানে ডেটা বাসটা কত বিটে ফর 8086 মাইক্রোপ্রসেসর রোহন?
Ma'am, 16 bit.
16 বিট। তাহলে কোড সেগমেন্ট রেজিস্টারটা কত বিট হোল্ড করবে? 16 বিট। ডেটা সেগমেন্ট কি হোল্ড করবে? 16 বিট। এক্সট্রা সেগমেন্ট 16 বিট। ক্লিয়ার? But AX hold 16 bit. Okay, but AH hold 8 bit. Clear? Data here is 16 bit. Data is not 8 bit. এখানে কিন্তু for 8086 microprocessor data is 16 bit. Okay, because data bus is 16 bit. It can process 16 bit data at a time. Okay, so the register is 16 bit. For 8085 microprocessor, we can microprocessor can access 8 bit data at a time. So all register are 8 bit. Okay, we can use this two 8 bit register as a couple. Okay, 16 bit register to hold the address, because for 85 microprocessor address is our 16 bit. Okay, now here address is 20 bits. Clear? So all register are, this is 16-bit register, this is 16-bit register. We can use 8-bit also, we can use 8-bit also, AX, BX, CX, DX. But CS, DS, SS, ES কিন্তু আমরা 16-bit হিসেবেই ইউজ করব, ওটাকে কিন্তু আমরা ব্রেক আপ করতে পারবো না।
मैम,
হুম,
अगर क्वेश्चन आता है कि जैसे हम लोग के पास 8086 में कितना जनरल पर्पस रजिस्टर है, तो जैसे एसपी बीपी डीआई एसआई हो गया 4, उसके बाद हम लोग
no, no, only general purpose register अगर पूछा गया तब तुम्हें लिखना पड़ेगा for 8086 microprocessor we have general purpose register for 16 bit general purpose register processor.
4 16 बिट जनरल पर्पस रजिस्टर्स.
हाँ, AX, write down the name AX, BX, CX, DX.
ओके.
Okay, if you want to write A for accumulator, B for base, C for count, D for data, you can also write this.
Okay, ma'am.
Okay, and each 16-bit register are subdivided into two 8-bit registers. If you want, you can use.
Okay, sure.
Clear? এই কোশ্চেনটা রোহনের ছিল? क्वेश्चन का काट ছিল?
मेरा मैम दर्शन।
ना ना, वो जो क्वेश्चन था जो आ, ये जो रजिस्टर 16 बिट है या 8 बिट है?
क्वेश्चन तो आप पूछे थे मैम।
नो नो नो, मैंने नहीं पूछे थे, कोई और पूछे थे। ये कौन है, ये कौन बोल रहा है? हाँ हाँ बोलो। हाँ बोलो, कट हो गया, मैंने हाफ सुना हाफ नहीं सुना। है इट, हाँ। अच्छा, तुमने रजिस्टर का नहीं पूछा था? मेमोरी कितने बिट स्टोर कर रहा है एट ए टाइम? अच्छा, कौन आंसर देगा? बोलो कौन। हम्म, तुहिन। तुहिन। তুহিন আছে?
Yes, ma'am.
হ্যাঁ বলো। ও রোহন একটা কোশ্চেন করছে।
Mm,
তোমার কি মনে হয় কত বিট স্টোর করতে পারবে মেমরি?
Rohan, can you say?
रोहन आरेकटा और एक बार क्वेश्चन पूछो।
Kind of 16. Yes, ma'am. 16 bit হবে কি ম্যাম এটা?
না, আমি তো কোশ্চেনটা করছি, রোহন তো তোমাকে করলো, আমি সেটাই করছি, অ্যান্সারটা কি হবে? আচ্ছা, আর কে বলবে? দর্শিত।
हाँ मैम।
बोलो।
टोटल हमारे पास 20 एड्रेस लाइन्स है ना। तो
20 एड्रेस लाइन है, कोई
तो
प्रॉब्लम
टू
नहीं
टू
है।
द पावर 20 मेमोरी में स्टोर हुआ, टू टू द पावर
हम्म,
20 आप लोग एक्सेस कर सकते हैं।
हम्म।
1 मेगाबाइट।
रोहन का क्वेश्चन है, वन मेमोरी लोकेशन contain 8 bit or 16 bit data?
हाँ ठीक है।
Just a minute. Message. One block of memory 8085 contain 8 bit data, so it is so in 8086 also each memory block contain 8 bit or 16 bit data. দেখেছো সবাই?
हाँ
Yes, ma'am.
16 बिट डेटा होगा ना। देयर आर 16 डेटा लाइन, तो 16 बिट डेटा स्टोर करेगा।
I think for 8.5 store 8-bit data, 8.6 also store 8-bit data, 8.8 16-bit data. Okay, one memory location store 8-bit data. Okay, each memory location store 1 byte of data because offset address start from 0000 to FFF. Rohan. Okay, maximum address is FFFF. Okay, so to address this particular memory location, we require 16 lines. Okay, and each memory location basically is 1 byte. Store 1 byte. Each memory location memory is 1 byte. Okay, so total is 64 kilobyte. Okay, so if we require 16-bit data, that means we require two memory location, consecutive two memory location. Okay, any other? Okay, तो दर्शित अटेंडेंस ले लेना, ठीक है? एक बार
हाँ मैम,
एक बार देख लो, मेरे पास वो आज तो मैंने डाउनलोड किया हुआ नहीं है, नहीं तो अटेंडेंस आ जाता है ऑटोमेटिकली क्लास का।
अच्छा ठीक है मैम, हम ले लेंगे।
शायद उसका नाम क्या है, वो छोड़कर बाकी सभी है। ऑनिक ऑनिक शेल, ठीक है?
ठीक है मैम।
रिकॉर्डिंग हो गया ना? हाँ, भेज दे सकते हो, ठीक है? तो मुझे एक्सेस दे देना। ओके, सो थर्सडे नेक्स्ट क्लास होगा। थर्सडे मैं एक बार सर के साथ बात कर लेती हूँ, ठीक है? सर अगर अनिमेश सर अगर